Hello viewers, welcome again. Still with our 2021 Mathematics revision of paper 2, that is by the Beacon Master. So let me take this opportunity again to thank you so very much, you our lovely viewers, for choosing to work with us and for supporting us. So there we go at number 4. Like I always say, paper 2 is not paper 2 without binomial expansion. So to the lovers of maths, let's see what this question is all about. So the question goes, expand the expression 1 minus 3x over 10 power 5. So we are told to expand this. Then we use our expansion to solve 0.97 power 5. So very easy, guys. Let's see. So let's assume an expansion of a plus b also being power 5. What do we always have here? So we shall have a, the powers of a will be reducing as those of b are increasing down the line. So a shall be power 5 when b is 0, a power 4 when b is 1, a power 3 when power of b is 2, all through until we have a now power 0 when b is bearing the largest power 5. So a is our 1 and b is minus 3x over 10. So substituting where each factor that is, then we shall have each factor, then we shall have 1 of course power 5 with our minus 3x over 10 power 0 plus 1 power 4 minus 3 over 10, that is minus 3x over 10 power 1, that is 1 power 3 minus 3x over 10 power 2, 1 power 2 minus 3x over 10 power 3, then 1 power 1 minus 3x over 10 power 4, and finally 1 power 0 minus 3x over 10 power 5. There we are. I hope we are together up to that stage. Then we continue. So 1 power anything will not change. 1 power 5, 1 power 1, 1 power 2 will not bring any change. So our big deal is with the minus 3x over 10. So any number power 0 is always 1. So we shall have 1 here and we shall have 1 here. So the answer therefore there will remain 1 power 5, which is a 1, plus this now will be minus 3x over 10 plus coming here we shall have a plus because when we square the negative it shall be eliminated. So what do we have here? Shall have 9x squared over 100. Each factor is squared, so let's fill the rest. That is going to be minus 27x cubed all over 1000 plus now 81 x power 4 all over 1000, no 10,000, plus that is minus 243 all over 100,000. So there guys, there we are. A follow through binomial needs a lot of concentration and being keen. So of course we shall have 1 minus 3x over 10 plus 9x squared over 100 yes, plus minus that is 27x cubed over 1000 plus 81x power 4 all over 10,000, then minus 240. Of course, we had a x here, power 5. 243x power 5 all over 100,000. So we are going to insert the coefficients. And coefficients, let me come over this side. I want to show the learners how to get the Pascal's triangle. Pascal's triangle, we have it as 1, 1, 1. Adding these two is 2 at the center. Close it with 1. Then 1 plus 2 is a 3 at the center. Is a 3 at the center. Close it with 1. This is 4 at the center. 6. 4. Close it with a 1. We can continue all the way to, of course, 1 plus that is 5. 10. 10. 5. 1. 1. So we can continue all the way to whichever power we were in need of. So like for our case, we wanted the powers of 5 under the Pascal's triangle. So we are substituting now, on our equation here, on our expression, I mean. So the first, of course, we shall have 1 by 1 is still 1 plus 1 plus minus. So let me just have 1 minus minus 3x over 10 times 5. So we shall have minus 15x over 10 plus the factor here is now 10 times coming over 10 times the third factor, it will be 90x squared over 100. So we shall have 90x squared over 100 minus 10 by 227, so it shall be 270 power 3 all over 1000. Then plus this other side we shall have by 5 it shall be 45 x power 4 all over 10,000. Then lastly we shall have a minus with 1, there will be no change, 243 x power 5 all over 100,000. So there we go, and there we go. So simplifying where necessary, so we shall have 1 minus 1.5x plus this is 9x squared over 10 minus 27x cubed all over 100 plus, of course, 5 goes here, 81, 5 goes here, 2, 1, 2, 3, so 81x power 4 all over 2000, then finally minus 243x power 5 all over 100,000. So we were told to leave our answer in simple fractions, so we shall have 1 minus 3 over 2x, that is 1.5. Of course, these other ones, we just bring them down. Minus 2 that cubed over 100. The rest shall remain the way they are because there's no any other common factor in each case. So we shall be left with them like that. So that shall become our expression. So we are being told later on to use the first 3 the first three terms to solve another part of the question. Here it is. Use the first three terms of the above expansion to solve 0.97. So we are told use it to solve 0.97 power 5. So the first thing we are going to do is to equate this with the expression that was given, that is 1 minus 3x over 10 power 5. So power 5 represents power 5, and therefore their bases are also the same. So 0.97 is equated to 1 minus 3x over 10. Collecting like terms, one shall come to be a minus, we shall remain with a negative 0.03 is equal to negative 3x over 10. Multiplying by 10 both sides, we shall have 0.3 is equivalent to negative 3x. Of course, this is still negative, so negative 0.3. Dividing by negative 3 on both sides, then x shall become 0.1, because the negative cancels as 3 cancels with 0.3 to give us 0.1. So substituting in our first three terms, like we are told to use the first three terms, so it shall be 1 minus 3 over 2 into x, and x is 0.1, plus 9 over 10 into 0.0. We are squaring 0. That, so we shall have 0.01. Guys, there we are. Always follow your teacher. So what do we have here? 1 minus, this is 0.3 over 2 plus 0.09 all over 10. So what do we have here? This is 1 minus 0.15 plus 0.009. So when you add this, what do we get? This is, we add first, then minus. So let me do it somewhere here. What do we add? We add first, so we shall have 1.009 minus 0.15. So as we minus here 9, here we borrow 9498. Of course, we borrowed from 1, it remained 0. So our answer becomes 0.849. So that becomes our final answer. So guys, binomial expansion, like I've said, requires a lot of concentration. You need to understand how we normally expand. I've taken a plus b in our case, then I've substituted being keen with the sign. We can see that there's an alteration. The signs alternates, negative, positive, all through until we reach there. Then I insert the coefficients, and I've taken my good time to show you, my learners, my lovely learners, how to come up with a Pascal's triangle. Very easy. So our Pascal's triangle, therefore, we substitute for the coefficients where necessary. We simplify, and there was our expression. Then we are told to use this expression only for the first three terms to be able to tackle this. Then I said the first thing, we equate the two expressions. Now they were all of powers of 5. Power represent power and the base represent base. Collecting like terms, we are able to get x as 0.1. Substituting, there we got, and we shall reach there. Please just believe in yourself. You can never miss a question on binomial expansion in paper 2, guys. Please, those 4 marks are free and I've given you as we promised. So do 1, do 2, do 3 until you become a master. Please, guys, subscribe and share knowledge. Those ones who reach Mr. Beacon Master, please 0720 9685 and 17. Bye bye.